Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Data Structures in Python, Part 5, Queue, Implementation of Queue as List, Creating a Queue using List, Inserting an element into a queue, Enqueue, Checking the queue status, Deleting elements from a queue, DQ, Traversal of queue elements for the class 12 students of computer science. So, let's dive in and get started. In our previous videos, we delved into the implementation of stacks. Now, let's embark on the journey of implementing queues using Python lists. Similar to stacks, queues involve a sequence of items, a linear list, but they come with specific rules governing how items can be added and removed from this list. In a queue, deletions occur at one end of the list, while insertions happen at the other end. Now, look at the definition. A queue is a linear data structure used in computer science and data management. Queues follow the first in, first out (FIFO) principle, meaning that the element that has been in the queue the longest is the first to be removed. It is a linear collection of elements, arranged in a sequential order. The operations performed are Enqueue. New elements are added at the rear or tail of the queue. DQ. Elements are removed from the front or head of the queue. Let's see queues in our day-to-day life at various places such as waiting in line at a supermarket checkout, passengers at the bus stop, vehicles in queue for filling gas at the gas station, people waiting to use ATM, etc. In all of these cases, the first person in queue is served first and others can enter the queue only at the end. Thus, a queue is called FIFO, first in, first out data structure, where the item first inserted is the first to get removed. Queue is known as FIFO first in first out approach or FCFS first come first served approach. Look at the example picture. First yellow car into the gas station is the first car out from the gas station. Remember, queue is a linear data structure that follows FIFO policy. Let's discuss about queue in Python. A queue consists of two open ends, front and rear. You can see the front and rear ends in this picture. Data can only be removed from the front end. That is, the element at the front end of the queue. A new data element can only be added to the rear end of the queue. In Python, an empty list is created using the list function. This empty list can be used as a queue data structure. When using a list as a queue, the rear and front of the queue are initially both set to the 0th position in the list. This configuration represents an empty queue with index values starting from 0 and no elements present. In this queue representation, elements are inserted at the rear end. Deletion of an element is performed from the front end of the queue. Similar to a stack, a queue can hold data objects of heterogeneous, multiple, types. You can see here the list containing values of different data type. A queue is a specialized list, data structure, which performs only two operations, that is insertion and deletion. Elements are always added from the rear end of the queue and removed from the front end of the queue. Now, we are going to discuss about the basic operation carried out by a queue as a list are. Creating a queue using list. Inserting an element in a queue, Enqueue, checking the status of queue. Deleting elements from a queue, DQ, traversal or displaying queue items. Before entering into the basic operations, some key points to remember. In Python, there's no need to implement overflow operations for queues. This is because Python is a dynamic language, and it doesn't require creating lists with a fixed size. As a result, you will never encounter a situation where the queue is full, eliminating the need to handle overflow scenarios. In Python, creating a list allocates memory and can store a variety of elements, regardless of their data types. Similar to how you can create a stack using the Python list function, you can create a queue in the same manner. The syntax is queue equals list function. That is, an empty queue is created as a variable of list data type. The syntax can also be written as queue equals empty list. It means queue variable is an empty queue as it does not contain any element. Initially, when you create an empty queue using these methods, it doesn't contain any elements. When you add the first element to the queue, it is placed at queue of index 0, and both the front and rear positions are at 0. Subsequent elements are added incrementally, with the front position remaining at 0 and the rear position increasing by 1 for each new element added. This linear structure of a queue can be implemented using a Python list. Now, we're going to discuss about inserting an element in a queue. Enqueue. Let's learn about inserting an element in a queue, that is, enqueue. Enqueue operation adds a new element to the rear end of a queue. Elements can be inserted into the queue as long as there is available space. Attempting to insert elements beyond the queue's capacity leads to an exception called overflow. To insert an element into a queue, the rear position is increment to accommodate the new value. In Python, the append function is used to add elements to a list, which can simulate a queue. Let's see an example. If we want to insert 5 elements, 27, x, 3.6, 89, y, into a queue using a list. Step 1. Initially, the queue is empty, with both front and rear at the same position. Step 2. Insert the first element, 27, into the queue with front equals 0 and rear equals 0. Queue becomes list containing element, 27. Step 3. Next element x is inserted into the queue with front equals 0 and rear equals 1. Rear is increment by 1 and the queue becomes list containing 27x. In step 4. Insert another element, 3.6, into the queue with front equals 0 rear equals 2. So rear is increment again and the queue becomes a list containing elements, 27, x, 3.6. In step 5. Insert another element, 89, into the queue with front equals 0 rear equals 3. So rear is increment again and the queue becomes a list containing elements, 27, x, 3.6, 89. In step 6. Insert another element, y, into the queue with front equals 0 rear equals 4. So rear is increment again and the queue becomes a list containing elements, 27, x, 3.6, 89, y. Have you noticed that, in these 6 steps of inserting elements into a queue, all insertions occur at the rear end? And also, the index value for the rear position changes with each element insertion. In contrast, the index value for the front position remains constant at 0. When the last element is inserted, front stays at the 0th position, while rear reaches the 4th position of the queue. This process of inserting an element into a queue is called enqueue. The position of rear changes with each insertion, allowing elements to be added at the end of the queue. In Python, list function append is used to add elements to the queue. The syntax is queue.append of x. Here, x is the element to be inserted at the rear end position in the queue. If the queue is initially empty, adding element x places it at both the front and rear positions, where front equals 0 and rear equals 0. Let's see an algorithm to insert an element into a list queue. Step 1. Start. This step serves as the starting point of the algorithm. It indicates the beginning of the execution of your program. Step 2. Queue equals list function or queue equals empty list. In this step, we initialize an empty queue using a Python list. We have 2 options to achieve this. Queue equals list function. This line creates an empty list using the list function constructor. Queue equals empty list. Alternatively, you can create an empty list using square brackets. The purpose of this step is to create an empty data structure that will represent your queue. Step 3, element equals input of, enter the element to be added to the queue. In this step, we prompt the user to enter an element to be added to the queue. Input of, enter the element to be added to the queue, is used to display a user-friendly message and collect input from the user. The element entered by the user is stored in the variable element. Step 4. Queue.append of element. In this step, we add the element entered by the user to the end of the queue. Queue.append of element is the command responsible for adding the element to the list, queue, represented by the variable queue. This operation simulates the process of enqueuing, adding an element to the rear of the queue in a typical queue data structure. Step 5. Stop. This step marks the end of the algorithm's execution. It signifies that the task of adding an element to the queue has been completed. Note that the built-in list function append is used to insert elements at the rear end in the queue. Now, we're going to discuss about checking the status of queue. We are going to learn about how to check the status of queue. The constructs which are used to monitor the queue's status when adding or removing elements from it are underflow, peak function, and overflow. Underflow. It checks if the queue contains any elements. That is, it's employed to verify if the queue is empty. This verification is crucial to prevent errors when attempting to remove elements, dequeue, from an empty queue. It helps ensure that dequeue operations are performed safely without trying to remove elements from an empty queue. Let's see the algorithm to check an empty queue. Step 1. Start. This step marks the beginning of the algorithm's execution. Step 2. If queue equal to empty list. Or if not queue or if not len of queue. In this step, you are checking if the queue is empty using different conditions. Any of these conditions will be true if the queue is indeed empty. Here's what each condition does. If queue equal to empty. This condition checks if the queue is an empty list. If not queue. This condition checks if the queue evaluates to false, which happens when it's empty. If not len of queue. This condition checks if the length of the queue is 0, which indicates an empty queue. If any of these conditions is true, it means that the queue is empty, and the program proceeds to the next step. Step 3. Stop. This step signifies the end of the algorithm's execution. Next construct, which is used to monitor the queue's status when adding or removing elements from it, is the peak function. Peak operation is used to view elements at the front end of the queue, allowing us to see them without actually removing them out of the queue. Let's see the algorithm to display first element without deleting it using peak function. Step 1. Start. This step marks the beginning of the algorithm's execution. Step 2. If queue equal to empty list. In this step, we first check if the queue is empty using the condition queue equal to empty square brackets. If it's true, the queue is empty, we proceed to the next substep. Substep A. Print of queue is empty. If the queue is empty, this substep prints the message queue is empty to indicate that there are no elements in the queue. Substep B. Go to step 4. This substep directs the program to skip the next step, step 3, and proceed directly to step 4. Step 3. Print of queue of 0. In this step, if the queue is not empty, meaning it contains elements, you print the first element of the queue. Queue of 0 accesses the element at the front of the queue without removing it. This simulates the behavior of a peak operation. Step 4. Stop. This step signifies the end of the algorithm's execution. Next construct, which is used to monitor the queue's status when adding or removing elements from it, is the overflow. Overflow checking serves the purpose of verifying whether there is enough space in the queue to add more elements. Its primary goal is to prevent situations where the queue becomes too full, which could lead to errors or problems when trying to add elements using Enqueue operations. By performing overflow checks, you ensure that the queue's capacity is not exceeded, thereby avoiding potential issues during the addition of new elements. Now, we're going to discuss about deleting elements from a queue, dequeue. Let's learn about deleting elements from a queue, dequeue. It is mandatory to check whether the queue is empty before deleting an element. Deleting elements from a non-empty queue is done from the front end of the queue. The process of removing an element from a queue is called dequeue. Dequeue operation removes one element at a time from the front of the queue. Elements can be deleted from a queue until it becomes empty. Attempting to delete an element from an empty queue results in an exception known as underflow. In Python, you can use the built-in list function del or pop to remove elements from a queue. Syntax is queue.pop of 0. It deletes the element at the front end, index 0, of the queue. It returns the deleted element. It allows you to remove and retrieve the front element simultaneously. Another syntax is del queue of 0. It deletes the element at the front end, index 0, of the queue. It does not return the deleted element. It only removes the element from the queue without providing its value. To delete an element from the front end of a queue, use the pop of 0 function in Python. The zeroth position represents the front of the queue, so pop of a 0 removes the element at the front. After removal, all elements following the deleted element are shifted to fill the gap. Pop of a 0 returns the value of the removed element. This operation maintains the order of elements in the queue, effectively simulating queue behavior in Python. Let's see the algorithm to delete an element from a list queue. Step 1. Start. This step indicates the beginning of the algorithm, where the execution starts. Step 2. If queue equals empty list. This is a conditional statement that checks whether the queue is empty or not. The square brackets typically represent an empty list. Step 2. Continued. Print queue is empty. If the queue is empty, this line of code prints the message queue is empty to indicate that the queue does not contain any elements. Step 2. Continued. Go to step 4. If the queue is empty, the algorithm jumps to step 4, which means it will skip step 3 and proceed to the final step, step 5. Now, look at step 3. Element equals queue.pop of 0, or del queue of 0. This step assumes that the queue is not empty because it follows the conditional check in step 2. It involves removing an element from the front of the queue. Depending on the programming language used, you might use either the pop of 0 method if queue is implemented as a list, or the del queue of 0 statement to achieve this. The removed element is stored in the variable element. Step 4. Print element. After removing an element from the queue in step 3, this step prints the removed element to the output. Step 5. Stop. This step marks the end of the algorithm. The execution terminates here. Note that a queue is a data structure that follows the FIFO, first in first out, principle, allowing insertions at the rear and deletions at the front. Let's see an example. The list queue, which we created, holds 5 elements, 27, x, 3.6, 89, y. To remove these elements one by one from the queue front, the following steps have to be done along with the value changed for front and rear position. Now, look at step 1. A queue consists of 5 elements as shown here. Step 2. Execute pop of 0 or pop front function to delete or remove front element, which is 27. After deleting the front element, that is 27 from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. You can see in the last picture how the new queue has filled the gap and the list is shifted to one position towards the left. Step 3. Look at the first picture. Use pop of 0 or pop of front to remove front element that is X from the queue list. After deleting the front element that is X from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. Now, look at the second picture, how the new queue has filled the gap and the list is shifted to one position towards the left. Step 4. Look at the first picture. Use pop 0 or pop front to remove front element that is 3.6 from the queue list. After deleting the front element that is 3.6 from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. Now, look at the second picture, how the new queue has filled the gap and the list is shifted to one position towards the left. Step 5. Look at the first picture. Use pop 0 or pop front to remove front element that is 89 foot from the queue list. After deleting the front element, that is 89 foot from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. Now, look at the second picture. Here front end and rear end is 0, holding element Y. Step 6. Look at the first picture. Use pop 0 or pop front to remove front element, which is also the last element that is Y from the queue list. After deleting the front element that is Y from the queue list, the queue becomes an empty queue. Now, look at the second picture. It's an empty queue. So, we have performed 5 deletion operations, also called as dequeue, which results in an empty queue. Now, we're going to discuss about traversal or displaying queue items. Let's learn about the traversal or displaying queue items. Queue traversal is a method for accessing and displaying elements in a queue data structure. To traverse a queue, first, calculate its length using the built-in function len, and store it in a variable, for example, length. Use a for loop that starts from index 0 and continues until the length of the queue. In each iteration of the loop, display the element at the current index in the queue. Let's see the algorithm. Step 1. Start. This step marks the beginning of the algorithm, where the execution begins. Step 2. Length equals len of queue. In this step, the algorithm calculates the length of the queue, which is the number of elements it contains. The len of the queue function is used to determine the length, and the result is stored in the variable length. Step 3. For I in range of 0, length. This step sets up a loop that iterates through the queue's elements. It uses a for loop that starts from I equals 0 and continues until I reaches the value of length 1. Essentially, it goes through each index in the queue. Step 3, continued. Print queue of I. Within the loop, this line of code prints the element at the current index I in the queue. It retrieves and displays each element one by one as the loop iterates. Step 5. Stop. This step marks the end of the algorithm, indicating that the execution has completed. In the upcoming video, we will demonstrate how to write a comprehensive Python program that encompasses all the queue operations. Be sure not to miss it. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Watch the upcoming videos, Data Structures in Python, Part 6, Queue. Implementation of queue as list, Practical implementation, applications of queues, similarities and differences between stack and queue. You can check the link in the description box given below.